There we go. Right. So, what we have here is a beaker with zinc sulfate solution. Okay, so this is my zinc sulfate solution. Shall I put it like that? Zinc sulfate. It should be a colorless solution or a clear solution, but the zinc, I don't know, nobody can answer my question as to why it gets this brownish, it looks like rust. Okay, hopefully it will work. And here we have a copper sulfate solution, so that one is always blue. So I've got two beakers with electrolytes. Because of the copper ions and the sulfate ions, this is an electrolyte. Because of the zinc ions and the sulfate ions, this is an electrolyte. I want you to look on your table of reduction potentials. Which one is the stronger reducing agent?
Zinc.
Zinc is the stronger reducing agent. Okay. So if zinc is the stronger reducing agent, then zinc will be able to reduce copper 2 plus to copper. Am I right? Now, so if I would put a piece of zinc into the copper sulfate solution, you'll immediately see a reaction taking place. I don't want to damage my experiment. So what I'm going to do is I'm going to place the zinc into the zinc sulfate. So I've got the electrode, the zinc electrode, into the sulfate solution. And I'm going to place the copper electrode into the copper sulfate solution. And this measuring instrument here is called a galvanometer. It makes sense because it's a galvanic cell that I'm going to build here. On the burette stand there, I've got you remember the saturated salt solution that we made when we did the reversible reactions and the common ion thing. So I've poured this into what we call a U-tube, and I just want to block it because I'll have to turn the solution upside down. I have to block it with some cotton wool here so that it won't fall out. I discovered that this U-tube is, the two legs of the U-tube isn't the same length. That's why the one end, the liquid is on a higher level than at the other end. So there we go, saturated sodium chloride, sorry. It's saturated sodium chloride. And just plug the hole there. It's just salt, so it won't damage you. Now I pray it's going to work. You see, this is an open circuit. There's no closed circuit here, so current can't flow. Let's see what happens when we do this. Hey! The needle jumped to way above 36 millivolts. Can you see? If we take this out, it goes back to naught again. So the moment the circuit is closed, so there's a spontaneous reaction happening here. The moment we connect the zinc and the copper electrodes, that moment there's a chemical reaction taking place. So what will the chemical reaction be? You already told me that zinc is the stronger reducing agent. So what will happen to zinc? It will be oxidized. So what what does it mean? What will happen to this piece of zinc? The zinc will give electrons and send the electrons through the wire to the copper, and the zinc will change into zinc 2 plus ions. Okay, you got that? So this piece of zinc electrode will be corroded. It will fall into holes because the zinc atoms are going into solution as zinc ions. So zinc is oxidized, and that means that the mass of the zinc electrode is going to decrease. Are you with me? Okay. The electrons goes, it flows through the galvanometer, comes out this red wire, comes to the copper. Now this copper has got electrons on it. What will it do to the copper ions? The copper ions will come to it and take the electrons. So what is that called? Reduction. So the copper ions are reduced to copper atoms, and if I leave this, you can see on here the copper electrode is much smoother than the zinc electrode. The zinc electrode is pitted, where the copper just gets deposited onto the copper electrode. So what happens to the mass of the copper? It increases. Okay, so this is where oxidation takes place, the zinc half cell. This is where reduction takes place, the copper half cell. So this is the oxidation half cell, this is the reduction half cell. Alright? Now, more and more zinc ions are going into solution here. More and more copper ions are taken out of solution here. What's that going to cause? Here you'll have a negative charge buildup. Because remember, you've got the sulfate ions here. Huh? And for every sulfate ion, there's a copper ion. Now, if you take the copper ions out, there'll be only sulfate ions remaining there. So you've got a negative charge buildup there. And here on the other side, where the zinc is, you're pumping more zinc ions into solution. So you'll have a positive charge built up here. Okay? Because you're putting more Zn2 plus into the solution. But you're not adding sulfate ions to the solution. So here you have a positive charge build up. Here you have a negative charge build up. Now who will equalize that? In here we've got ions, sodium ions and chloride ions. So if you have a negative charge built up here, the sodium ions will tend to diffuse to this electrolyte here, or this half cell here, and the chloride ions will tend to diffuse to the zinc half cell there, to keep the charges balanced. Making sense? Okay. So the salt bridge has two functions. One, it completes the circuit. It closes up the circuit, it completes the circuit. And two, it prevents a charge buildup in the half cells by allowing the ions to flow from it to one of the to both of the half cells. Okay, is it making sense? It is therefore very important this is where it is important to know your solubility rules, because you can't put a salt in here that's going to form a precipitate with one of your electrolytes. So to grade 12s, that is where solubility rules is important. You need to realize what type of solution you can't use in a specific electrochemical cell. So if your electrochemical cell has lead or silver in it, it's better to use a nitrate salt, because all nitrate salts are soluble. Then you don't use sodium chloride, because lead will form a precipitate with a chloride. Lead chloride is insoluble. Silver chloride is insoluble. So that's what you need to remember here. Okay, I haven't defined the anode and the cathode yet. Okay, the anode is the electrode where oxidation takes place. The cathode is the electrode where reduction takes place. Okay. So the anode is the electrode where oxidation takes place, and cathode is the electrode where reduction takes place. In language you learn about vowels and consonants. So the vowels go together. Anode, oxidation. Anode, oxidation. I want to say k, but it's not k. C for cathode, consonant, reduction, R, CR. I remember it this way. A red cat chases a, and, what? No, man. A red cat chases, and, what? No, an ox. An ox chases a red cat. An ox chases a red cat. Well, you know the Spanish people with their red cloths and the bulls. That's what it makes me think of. All right.